Hello one and all, welcome back to Under the Hood of Python, a guide for complete beginners. In this session, we are going to continue understanding how does Python work, along with the different remaining components in its execution flow. If you remember right, in our previous lecture, we took a sample code something like this, which went through two major layers called as lexical analyzer followed by parser. And the parser created something called as an abstract syntax tree. Let's pick it up from where we stopped. What happens to the abstract syntax tree next? This abstract syntax tree will be fed into a unit called as a compiler, where it creates an object code or bytecode using the abstract syntax tree. Hold on for a moment. This bytecode is not something which will be directly executed on our machine. This is a specific object code to Python. So what happens to this Python object code? This will be used by a unit called as an interpreter to get executed on the machine. Let's take a look at how does this Python object code looks like. Before we understand what happens to this PyObject code, let's have a quick recap of what are the different layers which our English-like Python code went through. Here we go. The first ever unit that will be encountered by our Python code is none other than lexer or lexical analyzer, the output of which is fed into a unit called as a parser, and finally the compiler. What does lexer do? Lexer simply takes up the program and tokenizes the instruction into a set of tokens, feeds it into a unit called as parser to create a grammatically right abstract syntax tree, and this AST is again fed into a unit called as a compiler, which generates Python's object code or a bytecode. This entire flow of lexical analysis, parsing and bytecode generation is termed as compilation. Once the entire Python program enters into a compiler unit and generates PyObject code, this bytecode or PyObject code will now be fed into a new unit called as interpreter. This interpreter is also termed as Python virtual machine. What does it do? It simply interprets the generated bytecode sequentially. Let's now try to understand in detail how does this interpreter work. Before we get into the details of how interpreter works, what does it do by taking this PyObject code as the input, let's try to answer our first ever question of, is Python program getting compiled or interpreted? Here is our answer. Python program first gets compiled, during which the Python vocabulary or the grammar of the program is verified and a bytecode is generated. So now this bytecode generation process is termed as compilation. And further, this bytecode is served as an input to an interpreter unit, which then runs the necessary instruction on the machine. So Python is not just compiled nor just interpreted. Instead, it's a compiled and interpreted programming language. Compiled only till the PyObject or the so-called bytecode generation, and then on it gets interpreted to get really executed on our machine. Hold on for a moment. This is not the execution flow that will be seen by the program all the time. Yes, this flow of execution will be seen for the first ever time the Python program gets executed, or if we do any further modification and this modification is waiting for a rerun. In these cases, the Python program gets newly compiled and newly generates a bytecode and gets interpreted by the interpreter. So what happens to a program that's already executed and has not seen any modifications after that? Such programs during their next run simply skips the entire compilation process, and the interpreter reuses the already available or already generated PyObject code and easily executes the program. With this understanding, let us go inside interpreter to know what it exactly does to run the code on a machine and what this interpreter is all about. Interpreters can be of one or more types. Let us see the different available Python interpreters. There are majorly three types of Python interpreters. One is known as CPython, wherein the Python interpreter is implemented using C language. The next category is termed as PyPy, a type of interpreter implemented using Python in itself. The last category is known as Jython. As the name suggests, the Python interpreter is implemented using Java and requires JVM for its execution. In most Python programs, the standard interpreter under use is CPython. So let's have a deeper understanding of what CPython based interpreter or CPython based virtual machine is all about. As we discussed till now, a new Python code runs through a compiler unit to generate a byte code which is then fed into a Python virtual machine, which in our case is of type CPython. The interpreter performs the work indicated by the PyObject code or the bytecode instruction. In our example, let's say when the interpreter wants to execute the function foo, it reads the bytecode instruction of the function one at a time and does what they tell it to do. Let us now understand how does this Python interpreter looks like. This Python interpreter or the virtual machine is a loop that just uses the bytecode as the expression value to be evaluated in a switch statement to choose one among the many case statements in a huge switch case statement. What do we mean by that? Let us try to visualize and understand the same. Here we go. In the switch statement takes the bytecode as the expression to be evaluated and checks for one of the cases which matches it, and wherever it matches, the corresponding case is picked up and the statement inside that case will be executed on the machine. For example, in our case for the function foo, let's say we have a bytecode termed as load underscore constant, and it looks for this load underscore constant based case value, takes up the instruction present inside that case. So what does this case statement comprises of? It simply comprises of an already compiled C code for that specific PyObject code or the bytecode. And this is something which will be executed on the machine. So the bytecode passed as an input to the CPython interpreter will help the interpreter to choose one among the compiled C instructions present in the matching case statement to get executed on the underlying machine. With this, we got an end-to-end understanding of how Python works. Let us now wind up the session by taking a quick recap of what all we discussed in this section. In this session, we picked up from where we stopped in our last lecture. We continued by understanding how does this AST further gets used. It is fed into a new unit called as compiler to generate a bytecode or PyObject code, and then this is further used by the interpreter to get executed on the underlying machine. So is Python program getting compiled every time or interpreted every time? It's a combination of both compilation and interpretation based on whether it's a new program or an updated program or an already bytecode generated program. After which we took a deeper look at different types of interpreter and majorly understood the functionality of CPython interpreter, which is largely used by Py programs. Up next, we are going to take an example and understand how does this Python interpreter works. Till then, have a great time, take care of yourself, see you in the next lecture.